Today we're basically going to do the same thing we did last time, except this time we have a complete set of measurements from a 9-point array. So essentially what it is a center position. Let me just go through and show you this. We have O1 main left, O1 main right. This is the first measurement that was taken from the main listening position. Then we've done it again. So we have two measurements from the same spot, essentially to give me a little bit more of a bias to that position when I'm averaging them all together, which is something we're going to do in just a moment. So here I have measurements 5 and 6. This is left and right from a point on a cube, which is surrounding the main listening position. Okay, so this would be the first of those 8 points. These two are the second point on that cube. These would represent the third position. These represent the fourth position. Okay, and that's, again, 4 points on a cube. Okay, so that means there are 4 left. So that would be the next one. This represents the next one. This represents the next one. And this represents the next one. Okay, so every left and right pair represents a different position on a 3-dimensional cube surrounding the main listening position, which we have recorded essentially twice, right here. 1, 2, 3, and 4. Okay, so having 2 measurements from the center gives it a little bit more of a bias, like I said, a little bit more weight in the average. So what we're going to do to start off is come up here and time align all of these measurements. So it will timeline all of the measurements that are checked in the legend down here. So you can see the progress down here. We'll wait till it's done. Essentially what this is doing is aligning them all to that acoustic reference when the measurements were taken. So we'll wait for that to finish. Now that we've got them all aligned, what I'm going to do is go through and organize all of these. So I'm going to take all of the left measurements like this and put them together. This takes a little bit of time, but it's not too terrible. So give me a second to finish this up. Okay, so now we have them all separated by speaker. So here's all my left speaker and here's all my right speaker. And they show up down here as well together. Okay, so what I want to do is deselect all of the right speaker measurements like this so that I'm left with only the left ones selected. Okay, now what I can do is come through and just apply that psychoacoustic smoothing to all of them together. Okay, and what I want to do from here is create an RMS average. Okay, I can do this, or I can push this button down here, average the responses. For this, I am just going to use RMS average. All right, so what it does is it gives me a new measurement down here called RMS average 1, which I'm simply going to rename left. Okay, so this represents the average of all the measurements taken from that cube around my listening position. And specifically, the cube is probably about 1.5 feet by 1.5 feet by 1.5 feet, roughly. Roughly the distance of our shoulders here. Okay, so what I've done here is created an average of all of the measurements that I had selected. And since I had all of the left ones selected, I have an average for the left speaker here. Now, a shortcut that I can perform here is to right-click anywhere in this window and toggle the selections. What that does is it just swaps what's selected with what is not selected. So now I have all of the right measurements selected and I'm ready to create another average. Okay, so once again, I need to apply psychoacoustic smoothing and then create my RMS average. Now that I have that over here, I'm simply going to rename this to right. And now I can deselect everything, clear selections, and I'm only looking at my left and right averages. Okay, so these two measurements here represent the average of that three-dimensional space with a slight bias towards the center listening position because I gave it two measurements instead of one. So it's got a little bit more influence. Not much, but just a little bit more, just to help it out. From here, the process of creating my frequency response correction filters is pretty much the same as it was before. I'll take this measurement here, RMS left, come up to EQ, and I'm going to use the generic again. Full range speaker, yes, add room curve, just like before. What did I use last time? 0.5. Let's just do the same thing for the sake of consistency. So we'll use 0.5 for these values here. Now I need to find the level for my target. So I'm just going to move this down right about here. So let's just say 72.5 just to make it easy. I'm going to leave that there and go to the other measurement. Remember this number, 72.5. Come over to the right side, go back in here. We will give this 0.5 and 0.5 as well. And then here I'm just going to type this in, 72.5, and check it out. Looks like it's pretty good, right? So by averaging them together, look what we get. We get this nice match up here, and then on the left side we have pretty much the same thing. See, it's right here. This is perfect. I'm just going to leave it right here at 72.5. Come down here. These are, again, these are the same settings as before. Make sure that the range is from 20 to 20K. That's from here to here. And then simply click Match Response to Target. Say OK. Let the filter generation process commence and finish. This one's looking really clean. That's nice. OK. We'll go ahead and close that. Next thing we need to do is repeat that process for the right side. So come on in here. Make sure this is all the same again. Make sure we're using generic. Yes, we are. 20 to 20. Same settings. And run the filters. So again, we have this nice clean response. If you want to preview what it's going to look like in the window, you can go ahead and generate measurement from predicted. What that means is it takes this predicted response and it just generates a new measurement down here in your window using this data. We're not going to do that this time because it's not necessary. I did it in the other video to kind of just show you what we're talking about. But since we've already been through the process once, we don't need to do that again. Now that we've got our filters created, the next thing we need to do is export. So go up to File, go to Export. Export Filters Impulse Responses Wave. This one right here in the middle. Select Stereo. And then for the left channel, we want this one right here, RMS Average Left. For the right channel, we want RMS Average Right. So this one is correct. 32-bit float, normalize should be not checked, and then select whichever sample rate your playback is. Okay, so if your playback is 96K, tick this. If you flip back and forth between 48 and 96, check them both. It'll create two sets of filters, whatever you want. In my case, I'm just going to leave it at 48. Say OK. Now, from the last video, we've got this filter here. Okay, so what I'm going to do is just, I'm going to call this 9 point. So save that. And now you're done. This is all you need to do. So that WAV file that we just saved is ready to go. All you have to do is load that into your Convolver and you're set.